So we are 250 feet under the water. Actually, I'll do it like this. 250. He dives at an angle of 15 degrees with respect to a line that is parallel to the water surface. So this long line that we already drew is parallel to the water surface. We're going to use this as our baseline for one of our angles. We dive 15 degrees. When you dive, do you go up or down? Down, so we're diving downward 15 degrees. 15 degrees. For how long do we dive at 15 degrees?
1,500 feet.
For 1,500 feet. So for 1,500 feet, we dive, and then it asks how or what is the depth of the submersible after the dive. So how deep? So when it asks us how deep, we could be able to find what I've highlighted in orange as our depth. But does this orange truly show how deep this submarine is? Does it? How much was it already under the surface? 250. So it doesn't account for the 250 it was under the surface. We can solve for the rest of the depth of what we did during the 15-degree decline, and then we'll have to add it in with the 250 we were already under the water. All right, so can I use the Pythagorean theorem? No, why not? We have an angle. We aren't given two sides. So we're going to have to use a trig ratio. So we're going to need to decide which trig ratio. What kind of side is the side that's missing? Opposite. And what kind of side is 1,500? So which trig function are we going to use? Tangent from 15 equals the opposite. We don't know. We can call it x over the adjacent, which is 1,500. Do I need to flip this?
No.
No. I can just multiply both sides by 1,500. All right, so 1,500 times tangent of 15. We're going to round to the nearest whole.
402.
402. Reason being, only from where we started to go 15 degrees down to where we stopped is 402 feet. We were already 250 degrees below the surface, so we need to combine both numbers. So 402 and 250, what does that make? 652, and then you'd say feet. All right, that's why we did this one together. It's a little harder. So this is similar to the one where we did the kite, if you recall. For the kite, we had to account for the 5 feet from the ground to the spool. All right, we're going to then look at number, I think, 16. So flip. I believe it's 16. Yeah. In baseball, the lengths of the paths between consecutive bases are 90 feet, and the paths form right angles. The player on first base tries to steal second base. How far does the ball need to travel from home plate to second base to get the player out? So first off, what does a baseball field look like? Or the infield? A diamond. What do we know about the angles of this diamond? They're all right angles. That's what they tell us in the directions. My baseball players usually know the approximate amount, but it's not the exact amount. So that's what we're going to find. We're trying to figure out how far does the ball need to travel from home plate to second base. What is the plate all the way at the bottom usually? Home. And then first, second, I don't know what you said. Yeah, a little bit. So we're going from home plate to second base. So that would be a line. When we draw a line from those two bases, what type of shape are we talking about now? A right triangle. What is the distance from home plate to first base? 90. And from first base to second? 90. We want to find the length from home to second. So what will we do to figure out that length?
Pythagorean theorem.
the Pythagorean theorem. We have two sides. We're finding our third side, which would call for the Pythagorean theorem. So 90 squared and 90 squared equals x squared. Can anybody tell me what kind of triangle this is? Like, what are the other two angles? It is isosceles. So can anybody take a guess at what these two angles would be? They're going to be congruent, which would make them. What'd you say, Alex? 45 and 45. Because the two sides are congruent, that meant the angles across them are also congruent. Fun fact. Anyway, so 90 squared is 8100. 90 squared is also 8100 equals x squared. 8100 plus 8100 is 16,200. Take the square root. We are going to round to the nearest tenth. 127.3. My baseball players earlier on today, they already knew it was 120, but that wasn't the exact answer. They're off by a little bit. Questions on this one? Number 23 is very similar. If you look at number 23, it says find the distance from first base to third base. But it would be the same setup because it is a baseball diamond as well. So if you want to make a note of it, it's just like number 16, except for you're going to different bases. Okay? We are going to do number 17. A fire truck extends the 105-foot ladder against a 56-foot tall house. What is the angle between the ladder and the ground? So I think we can all agree, what is the horizontal line in this picture going to be? The horizontal line? The ground. The ground. All right, and then what's my vertical going to be?
56.
The house, which is 56. Okay, so here's my house. My windowsill with my beautiful flowers. You feel me? You feel me? No? All right, whatever. All right, and then what's my hypotenuse going to be? What is it going to be? Not what number? A ladder. Y'all got to focus on keywords before you focus on the numbers. And it does say the ladder is 105 feet. That is a very long ladder. Hence my longer-ish picture. All right, so the right angle is made with the house and the ground. It says, what is the angle made between the ladder and the ground?
90.
It is not 90, because this is not the ladder and the ground. Ladder and the ground are over here. Ladder, ground. What is this angle called? Angle of elevation. It is congruent to the angle of depression, so you're not necessarily right, but you're not 100% wrong either. They are congruent. All right, so we're solving for an angle. Can you use the Pythagorean theorem to solve for an angle? No, you cannot. We will have to use a shift, yes, but we need to figure out what trig function we're going to use. What kind of side is 56?
Opposite.
And then 105?
Hypotenuse.
So which trig function?
Sine.
Sine from we don't know, so x equals 56 over 105. We want to get rid of sine, so we have to use the inverse. So this is your shift. We are going to round to the nearest tenth once again. So when do we use this shift? When we're solving for an angle. Do you use it any other time? No. If you had typed in sine of 56 over 105, what would you have gotten? I just want to know. What would we have gotten? Someone type in sine of 56 over 105. You would get 9.3 with a scientific notation telling you the answer is actually 0.0093082. Does that sound like an angle measure? 0.009. That is less than 1 degree, which means you did something wrong. So make sure when you solve for an angle, you use the inverse so you can get a whole-ish number. All right? I was saying whole-ish, like... Sorry, some... soccer field is a rectangle, 90 meters wide and 120 meters long. The coach asks the players to run from one corner to the corner diagonally across the field. How far do the players run? So I've been telling my kids today, it doesn't say it, but we're going to find the total they ran. Not just from the diagonal or from the corner to the corner. We're just going to find how much they ran in general. So a soccer field is a rectangle. All right, so the length, the longer side would be 120, and then the width would be 90. It says the coach asks the players to run diagonally from one corner to the other corner. How far do the players run? So we want to find a length of our third side given two sides. So will we use trig ratios or the Pythagorean theorem? Pythagorean theorem. So we got 120 squared plus 90 squared equals x squared. The reason I mainly ask is the most common mistake was using the wrong thing on the quiz. You know how to use both, but just knowing when to use either. 120 squared is 14,400. 90 squared, 8,100. Add them together. 22,000. And then take the square root. We get 150. So this third side is 150. We still need to figure out how much they ran total. So what will we do with these three numbers? Add them. So 120, 150, and 90. What do we get? 360. So they ran 360 meters, which, if that sounds like a lot, that is less than a mile. For sure. That's a lot. Pretty sure one lap around the track is 400 meters. Does anybody run track? Yeah, 400 meters is one lap. 800 is 2 laps. So this is almost a half mile. Almost. We got one more, and it's 25. 25. So for this one, you're going to have to use a little bit of your common sense to go from the scenario to how to solve it. How many of you have ever moved, helped someone move, either from a room, from your house? 3 people, 4 people, 5 people? So you know when you move, when you move, you kind of have to think outside of the box sometimes to get something out of a room or into a room, correct? Because it doesn't always work that way, or work certain ways. So we have Jill's front door is 42 inches wide and 84 inches tall. What does a door look like? A rectangle, so I'm going to draw her door, 42 by 84. She purchased a circular table that is 96 inches in diameter. Where is the diameter? Yes, straight across, so 96 inches. Will the table fit through the door? So right off the bat, people are like, no. Yeah. What does this have to do with the Pythagorean theorem? So think about this. Obviously, it's not going to fit horizontally because it's 42 inches. It's obviously not going to fit vertically. What is another way to get something through a door? Diagonally. Diagonally. So here's what we need to find out. Is this diagonal, this is a terrible line, but forgive it. Is this diagonal, the distance from here to here, is it going to be wide enough to fit a 96-inch table? How do we figure out the length from the diagonals? The Pythagorean theorem. So I'm going to ask a little bit of a shortcut. Go ahead and type in 42 squared plus 84 squared. 8,800 what? 20. We still solve like normal. Take the square root. What does x equal? Approximately.
90, like.
I would say about 90. 94. About 94. So here is where your answer comes in. Did it ask the measure of the diagonal? No. It says, will the table fit through the door? Will it?
No.
No. And you need to tell me why. So it'd be a no. I'm not going to write it all. A no because the diagonal is not long enough to fit a 96-inch diameter. Something to that extent. So we're going to put this away. Your homework is to finish the problems. Your class has done more than any other class, meaning that's less for you to do tonight. So we are going to do a scavenger hunt.